Find the unit vector in the same direction as the vector v equal to negative 2I plus j. Now remember, in order to do this problem, you have to remember the formula for the unit vector in the same direction, or in the direction of v. Okay, the formula for this is 1 over the magnitude of v times the vector v. Okay, I will write with the arrow. So you have to find this number, then multiply the vector with the vector. So let's apply the formula here. First, we write, okay, v is negative 2I plus j, so you can write this one as negative 2 comma 1. So the magnitude, its magnitude is negative 2 squared plus 1 squared, and take the square root. It will be square root 5. So the unit vector here we want is 1 over square root 5 times the vector negative 2, 1. So this has to be, okay, I'm using this formula here. And this will be, okay, the scalar times a vector. You multiply the components. So we get this one. You know, as a practical thing, you can, after you check this one, you can directly divide those and square root 5, and you can get the result. So basically it's b. Okay, for u equal to 2I minus 2j, and for v negative 8I plus j, find the magnitude of the vector 2u plus v. First, let's calculate 2u plus v, which is 2 times 2I minus 2j, and plus negative 8I plus j. Then this will be 4I minus 4j, so you distribute. And then, okay, plus, you can remove the parentheses here because this is plus. It will 8I plus j. So you can add or subtract i's with i's. So it will be 4I minus 8I, so it will be negative 4I. And then negative 4j and plus j, it will be negative 3j. So what is the magnitude of magnitude? Magnitude is the square root of the square of the first one and the square of the second one, and the y component. So it will be 25, so which is 5. So let a be a real number if if the polar form of a complex number a times I minus 2a is square root 3 CIS of 5 pi over 6, then a equals to what? Okay, now what is given to us is this one, a times I minus 2a is equal to square root 3 CIS 5 pi over 6. So then we will calculate calculate a. Now we have to expand this one and match ai minus 2a squared is equal to square root 3. Okay, what is CIS 5 pi over 6? It will be cosine 5 pi over 6 plus I sine 5 pi over 6. And here we have to know what is cosine 5 pi over 6. So cosine 5 pi over 6 is equal to, if you change it to radian, it will be equal to 5 times 108 divided by 6, it will be 150. So it's 150 degrees, and 150 degrees is here. So we take its reference angle, so it has to be equal to cosine 30, but, and cosine is negative here, so we put negative. So in this case, cosine 30 will be square root 3 over 2. So we'll get we will get the value as negative square root 3 over 2. And when it comes to sine, we do the same thing. We change it to degree. And then sine is positive in the second quadrant. You know, here it's positive in the second quadrant. So then we will say sine 30, and which is equal to 1 over 2. And then let's put these values here. And then we have negative square root 3 over 2 plus I times 1 over 2. And, and then after this, after multiplication, we can match them. So 3, okay, it will be negative 3 over 2 plus square root 3 over 2i. So ai minus 2a squared. Okay, when we match them, okay, the real part is equal to the real part. So the real part is this here, and real part is this, and the imaginary part is this, and the imaginary part is this. So now, okay, we will match them. So a squared negative 2a squared is equal to negative 3 over 2, and a is equal to square root 3 over 2. Okay, we can solve this one, and we will get two values from here, but here this condition here, a is equal to square root 3, is directly telling you what a is, so no need to look at this part. So a is equal to square root 3 over 2. Now, if Z1 is equal to 2 CIS 50 and Z2 is 3 CIS 20 and Z3 is square root 3 CIS 40, then what is Z1 cubed times Z2 over Z sub 3 squared? Let's do it, and let's use some, okay, we have to use some properties here. The first property we can use is the Moore theorem. The Morse theorem, so which says, okay, 2 times CIS 50 degree cubed times 3 times CIS 20 divided by Z sub 3 CIS 40 squared. Okay, let's substitute all of them in the expression, and then remember this. So if you have the polar form of some complex numbers, and if you're taking the nth power, so it means equal to r to the nth times CIS n theta. So this is the Morse, or I don't know how it is pronounced. It's in French. The Morse theorem. Now let's apply it. It will be 2 cubed times CIS 3 times this. It will be 150 degrees times 3 CIS 20, and then square root 3 squared times CIS 80 degrees. So I'm using this one. Now after this, we have another property we can use here. The other property is this: when you multiply, okay, two complex numbers in polar form You can directly say this is R1 times R2 CIS theta 1 plus theta 2. You can add the arguments here, or the angles. So it will be 2 cubed times 3 CIS, this one, and this one will be CIS 150 plus 20, it will be 170 divided by, okay, I will say here this is 3, and now CIS 80. Now we have another rule for the division of complex numbers in polar form, which says R1 divided by R2 CIS theta 2, which is R1 over R2 CIS theta 1 minus theta 2. So I will use this one here. So 3 cancel out here. It will be 2 cubed times CIS 180 minus 80, so it will be 90 degrees. So it will be 8 times cosine 90. It will be cosine 90 plus I sine 90, and which will give us 8 times cosine 90 0. And okay, here I forget I, there has to be an I here. I times 1, so the answer will be 8I then. So the answer is D. Now let x be a real number and u, v be the vectors. X comma negative square root 3x and v is equal to negative x comma negative 3. First, find the values of x if u dot v is equal to 6. So u dot v is, let's write it, u dot v is, which is called dot product. And we do it this way. You write the vectors next to each other, and then we multiply the horizontal components, x times negative x. Then we add the product of the vertical components. So this will be negative square root 3x times negative 3 and negative x squared minus, it's plus 3 square root 3x. Now it says what is x if u dot v is equal to 6. So this will be equal to 6 then. So we have to find the solution of this. So I can, send this one, send x squared to the other side and negative 3 squared 3x to the other side. So I will end up with this. So I'm sending these. You can also check, you can send this one to the other side, but I want the coefficient of x squared to be positive. So now this is hard to do, so I will try to do it with the quadratic formula. You cannot factor it easily. So minus b, so which is 3 square root 3. You see minus minus, it makes plus. Minus plus square root. It will be, let me write this here, negative, okay. And then b squared is, okay, negative square root 3, negative square root 3 squared minus 4 times a times c divided by 2a, 2 times 1, here this is 1 you see. And now it will be 3 square root 3, okay, this one will be positive, and then plus minus square root of, okay, 3 square root 3 squared will be 27 minus 24 divided by 2. And we will end up with, okay, I will write here, x is equal to 3 square root 3 minus or plus square root 3 divided by 2. And now we have two values of x. So one is 3 square root 3 plus square root 3 over 2, which is, if you do it like 4 square root 3 over 2, which is 2 square root 3. That's the first one. Or we will have x equal to 3 square root 3 minus square root 3 divided by 2, which makes 2 square root 3 over 2, which is square root 3. So we have two x values here. The x values are 2 square root 3 or x equal to square root 3. Now, let x be a real number, u, v be the vectors as u equal to x, comma, negative square root 3x, and v is negative x, negative 3. Then if x is equal to square root 3, find the angle between the vectors of vectors u and v. Now, the angle, okay, we have to remember the angle formula here. The angle between the vectors u and v is, okay, it's found by this formula, cosine inverse of u dot v, dot product here, divided by the magnitude of u times the magnitude of v. So the length of u, the length of v. Now, when x is equal to square root 3, okay, let's write u. U is equal to square root 3 and negative square root 3 square root 3. It will be equal to square root 3 comma negative 3. Now, v is equal to negative square root 3. So for x equals square root 3, it will be negative 3. Okay, I'm using this one. Now, okay, what do we need here in this formula? We need u dot v. So u dot v is equal to square root 3, negative 3, and then negative square root 3 and negative 3. So we will have square root 3, negative square root 3, it will be negative 3, and negative 3, negative 3, it will be plus 9. So it will be 6. Now, the norm of u, or the length or magnitude of u is, okay, it will be, okay, look at here, this is square root of square root 3 squared and minus 3 squared, which makes 9 plus 3 squared 12, so which makes 2 square root 3. And then v, norm of v, or the length or the magnitude of v, it's the same thing as you see here. So it will be, okay, negative square root 3 squared and negative 3 squared. This will be square root 12, and which is equal to 2 square root 3. Now let's put them. Now we are ready to find the angle. Cosine inverse of u dot v is 6. We found it here. This is the dot product between u and v. Now it's 6 over. What is this? It's square root 12. Okay, 2 square 2, 2 square 3, and 2 square 3. Okay, you can also write the 12 there. So you will get here 4, 3, so 12 again. So you have cosine inverse of 1 over 2. Okay, the question is now, okay, what makes, which angle makes cosine equal to 1 over 2? Cosine of which angle is 1 over 2? Okay, it has to be something like 30 or 60 degrees. And we know sine 30 is, okay, 30, 60 triangle. This is 60, this is 30, this is 1, this is square root 3, and this is 2. And it will be cosine 60 will be 1 over 2 because cosine 60 مجاور divided by مقابل مجاور divided by وتر, that will be 1 over 2. So what we look for here is 60 degrees. So the angle between two vectors is 60 degrees. Complete the following statements. The complex numbers have the same, okay, same what? So we can look at some concepts about complex numbers. We can check the real parts, they're not the same. And we can check the imaginary parts. 2 and minus 2, no. So one other thing we can check is the modulus of z, the modulus. So modulus means the length of the complex number, we can say it's minus 1 plus 2i, and here it will be minus 1 squared plus 2i, 2 squared, squared 5, and here 1 minus 2i is equal to squared 1 squared plus minus 2 squared is equal to squared 5, which is, yeah, they're the same, so we can say they have the same modulus. Okay, if the norm of z is equal to 2, then what's z to the modulus of z to 20? Okay, what is this? So here is the idea here. If z is, z can be written as z times cis, like cosine theta plus I sine theta. And when you take the n power or 20th power of this, it will be the 20th power of the norm, and then cosine 20 theta plus I sine 20 theta. So this is De Moivre's theorem or rule. So if you take the n power of the CIS, so you can write it as 20 times theta on the side. So this part, it's when you take the modulus of this part will give you 1. So this part will give you the modulus of z20. So we need this is equal to, it's a general rule. You can take this 20 out, and you can say this is 2 to 20. Okay, regardless of what we did here, this is a general rule. If you want to take the modulus of z to something, so you can take the power of the modulus of z. So what is the argument of negative 5i? Now, we can write z, negative 5i, as the norm of z, or the modulus of z times cis theta. And this theta here is, we call it argument of z. Now, what is z? The norm of z is equal to, okay, say 0 minus 5i. Its modulus will be 0 squared plus minus 5 squared, then take the square. So this is clearly 5. So now we are matching this now. Okay, let's keep this aside. So minus 5i will be equal to 5 times the norm of z times cis theta, which is cosine theta plus I sine theta. So if you want to match the real part with the real part and the imaginary part with the imaginary part. The real part here is 0. So 5 cosine theta will be equal to 0. And when you match the I part here, so you will get 5 sine theta is equal to minus 5. So we are looking for an angle which has theta equal to, cosine theta is equal to 0 and sine theta is equal to minus 1. So which angle is this? This angle is clearly 270 degrees. This will be 270 degrees. For the other, we generally use the arctangent, but here using arctangent will not work because we will have an undefined value here because the tangent is undefined at pi over 2 and 3 pi over 2. So here in this problem, using alpha equal to tangent inverse like 5 over 0 will not work here. Will not work, by the way. Not work because this is undefined. So which angles are making it undefined? It might be 90 degree or 270. So this is not the way we go here. And when it comes to this question, if the vector u is equal to b minus b is a vector, unit vector, b is equal to what? Okay, b, the unit vector means this, then the modulus of u is equal to 1. So if you take the norm of this, so it will be b squared plus minus 2b squared square root, which is equal to 1. So when you look at this here, it will be 5b squared um, square root is equal to 1. So this gives 5b squared is equal to 1, and then b squared is equal to 1 over 5. And we have two options here. We say b equals either minus 1 over square root 5 or b equals 1 over square root 5. So it means b equals minus 1 over square root 5 or 1 over square root 5.